Hey everybody, welcome to the Tone Church. Just have a quick little video today. What we are doing is testing resistor values being used as dropping resistors for indicator LEDs on guitar effects pedals. That's a long-winded way of saying what's the appropriate value for an LED on your pedal, like your bypass switch on and off. What is the appropriate value to get a proper brightness? So when you click your pedal on, it's not too dim, it's not too bright. And another consideration which I have been dealing with is when I make pedals, part of making your own pedals is having fun and using different colored LEDs to make them look cool. And this pedal here is an Ion Effects Redshift, which is a sort of a clone of a Blackout Effects Whetstone phaser. So it has three indicator LEDs. We have the on-off, and then this has like two channels. You can switch between channel A and channel B, and depending upon which channel is on, either this LED or that LED will be lit. The problem I ended up having is this guy right here is nice and bright, but these guys right here are a little bit dim. And it would be a little bit nicer if they were all the same brightness. Does that make sense? Alright, so this is the test setup. We're using our pedalpcb.com breadboard here. And this is the circuit we have. We have 9 volts coming in from a power supply. And it's going through a 470 ohm resistor. When you buy LEDs, oftentimes it'll come with their own package of resistors, and this is the package that came with these, 470 ohms. Then we're going into a 10K potentiometer, and we've got this set up as a variable resistor, so we can vary the resistance from 470 ohms to all the way up to 10,470 ohms, or thereabouts. So we got our 9 volts coming in, gets dropped by the fixed resistor, and we can adjust the potentiometer to adjust the brightness of the LED. Comes out of the pot, goes through the LED, and then it goes to ground. Very, very simple. Alright, most of the time on these projects, the dropping resistor that they call for is like a 4.7K. That seems to be the standard. So that's where we have it set up for right now. But 4.7K isn't always the best choice. So I'm going to go through all the colors. And we're going to write down our findings in this little chart, and we'll make your nice little handy reference for myself and hopefully for you when you make your pedals. You can have nice LEDs, all the same brightness, of an appropriate brightness, blah, blah, blah. All right, let's do the test. Here we go. Okay, we have our experiment set up. We have a red 5mm LED installed. And to my eyes, the typical standard 4.7K with a red LED is good. So that's going to be our base. I know it's going to be hard to see, but we'll run the experiment so you can see what I'm doing here. Turn this guy on. Here's the LED right here. And that's a nice brightness right there with 4.7K. The multimeter is measuring the total resistance of the fixed resistor in series with the potentiometer. Now, if we were to take an orange LED, and we're going to run them in parallel, so the red's going to get a little bit dimmer, but you'll still be able to see the difference, or I will. I don't know how well you'll be able to see it on the camera. But if we install the orange one next to the red one, all right, turn it on, and we can see the red LED, or at least I can, hopefully you can too. The red LED is a little bit brighter than the orange LED. I would call that not bright enough for a pedal indicator, bypass indicator LED. We'll pull them out. You can see the red one gets a tiny bit brighter, but shut this off. Throw the orange one in there. Turn that back on. So now what we're going to do is lower the resistance until that becomes an appropriate brightness. Yeah, right about there. That looks good. So we'll shut that off and we'll get our measurement. And 470, we're all the way down. So the 470 ohm fixed resistor that comes with the kit is appropriate for an orange LED. All right, does that all make sense? All right, I'm going to go through and test all the different colors, and then I'll report back my findings. All right, our experiment is complete. Here are the findings. And as is often the case when you do experiments, it usually leads to more questions and will probably have to lead to further experiments. Now, I had the hypothesis that there really shouldn't be any difference in the resistor needed to get a certain brightness between the 5mm and 3mm LEDs. Because if you look at their forward voltage ratings, they're almost identical. All right, and that was not the case. So the 5mm red, the 4.7K was good, but the 3mm red, we had to go way down. 510, a 470 ohm resistor would be fine to get a similar brightness. But on other colors, it was the same. For example, the white LEDs, 3mm, a 4.7K was good, and on the 5mm, a 4.7K was good. So, further experimentation needed. I found that the forward voltage rating really had no bearing on which resistor would be good for it. As you can see, like the red, the forward voltage rating is between 2 and 2.2. The orange is the same, between 2 and 2.2. But to get a similar brightness to the red with a 4.7K, the orange needed a 470 ohm resistor. So that was another finding I had. Now, we'll have to do further experimentation to see between different manufacturers to see if that makes a difference. I guess my hypothesis was the resistor needed based more on the actual color of the LED. If you learn more about the way these are manufactured, I figured that would have more of a bearing than, actual who made them. So we'll have to do some more apples to apples experimentation between different companies. The 5mm LEDs I had were made by Edulec, and the 3mm were made by Chanson. So we'll have to do further experimentation. But what I can say is Edulec and Chanson are both readily available. You can get them at Amazon. I've used them forever. And these are one of the components that I haven't felt the need to, try and get more higher quality or whatever, bigger manufacturer name brands or whatever. I've never had a problem with LEDs ever. So these are fine if you want to grab some from Amazon or wherever. These thumbs up on these brands, I guess is what I'm saying. But these are the findings, and these are the resistors that I believe would be good to use to get a nice bright LED on your pedal. And they should all be, if you use these resistors, in different colors, they should all be a very similar brightness. A couple of notes: the green 5mm was bright, even up to like full resistance on the test setup, which is like 10.5K. And you probably don't want to go higher than 10K on a dropping resistor for reasons which are beyond the scope of this video here. The ultraviolet ones, even all the way down to 470 ohms, they were acceptable, but they were a little bit dim. And again, you probably don't want to go below 470 ohms. If you go too far down, you'll just, blow up your LED. So I recommend you don't go any further down than that. Just note that they are a little bit dim, but they are usable. What else? The green 3mm at 4.7K was a little bit on the bright side. And that was even when I turned up the resistance all the way up to 10.5K. It was still pretty bright. One thing you can do, I don't have one in stock, but I have one similar. Pedal PCB makes these breakout boards, and they actually have one. This is for your double throw, triple pole foot switch, and it has a spot for the LED, and then it has a spot for a fixed resistor in series with a trimmer, so you can install all that stuff on the little breakout board here, and you can fine-tune the brightness of your LED. and they're like $1 a piece. So they're that's an option for you. Very similar to this. pedalpcb.com. I don't get paid by them. I actually pay them a lot of money for all the stuff we do here. But there you go. Hope this is helpful for you, and we'll see you in the next video. Until then, rock on and prosper.
Done!